The next step in reducing CSAT to SAT is we need some gadgets to convert a circuit into a satisfiability formula. So we need some basic formulas that in fact we already visited before, but let's just do a recap so you remember what's going on. So one formula we need is this Z equals intersection X and Y, right? So it's three variables, and this is the truth table of this formula, right? And now we just fill it up, right? So what do I mean by fill it up? We take the zeros of this table, and for each one of those zeros, we are going to get a tree clause, a SAT clause that is 0 on this entry in the table and 1 everywhere else. And then we are going to take the intersection, and that would be the equivalent tree SAT formula for this thingy, right? So we go to the three zeros, right? For each one of those columns that is 1 everywhere and 0 everywhere, in the top we have the tree SAT clause that corresponds to it, right? It's easy to derive those things because you just read the input value and it's immediate what tree SAT clause you need to get, so it's 0 in this array, and then you take the intersection, right? And the intersection is what we want. The intersection would give us a tree SAT formula that is equivalent to the original formula. The reason is because every one of those clauses zero one of the rows. So if we zero all the rows where this original formula have zeros, then we'll get an equivalent formula. So that's how you do that. Right, this is, I believe is a, right, so this is another way of writing it down explicitly, right? For every row that is 0, you write down the tree SAT clause that is 0 on it, and you take the intersection. Nothing new here. And now you can do optimization. You can, since we are going to reduction to SAT, not tree SAT, we can eliminate some variables and get a slightly shorter SAT formula. You know, if you care, you can do it. If you don't care, that's quite okay, quite legal. Now we can do the same thing for the formula Z equal X or Y. Same argumentation, same way, you get the formula. Again, you can do some optimization and you get this identity. Right? This formula is equivalent to this. And similarly, we can derive a formula for the negation. So Z equal to not X, we have two variables, and this is the equivalent to SAT formula. One can see it directly. So as such, we get this lemma that gives us three identities saying that each one of those thingies is equivalent to the tree SAT formula written here, right? So we will use it shortly when doing the reduction. And I wanted to do it separately so it's clear how we arrive to those black box formula that we are going to use shortly.